Welcome and thank you for attending our presentation, Mochii ISS National Laboratory Portable Spectroscopic Electron Microscope. I'm Chris Owen, CEO of VOXA, and I'm delighted to update you all on progress towards placing microscopic imaging and elemental analysis on ISS, and to share with you how you might be able to use Mochii onboard ISS for your own microgravity research. While powerful analytical capabilities are available on ISS, many samples cannot be sent back to the lab, are extremely time critical, or evolve or might be destroyed during transit. One example is the 2013 EVA emergency that occurred with Italian astronaut Luca Parmitano, whose EMU suit suddenly started flooding with water during a routine spacewalk. The particles found inside the fan pump separator in his suit were only identified by electron microscopy after the suit was returned to Earth. American spacewalks were suspended immediately following the emergency and only resumed 17 months later. If ISS had electron microscopy on board at the time, the root cause could have been identified and potentially mitigated in days rather than months, allowing a return to full ISS capabilities, including spacewalks, much earlier. At VOXA, we developed a new portable imager and spectrometer called Mochii for unprecedented in situ diagnostics in science. Mochii combines the best of both light and electron microscopes in the size of a coffee maker. In particular, it can provide nanostructure and material composition identification by way of SEM imaging and energy dispersive X-ray spectroscopy. Mochii's coffee maker footprint weighs less than 15 kilograms and consumes less than 100 watts of power. Due to its portability, it mitigates the need to send samples back, is remotely operable via tablets or phones, and fits in the overhead bin of an airplane. Mochii is just as at home on vehicles, whether on ocean vessels, oil rigs, or even space vehicles, as it is in the lab. We've tested in various environments ranging from undersea habitats, laboratories, and home kitchens, and we're now deploying onto the International Space Station as part of a NASA SBIR Phase 3 commercialization agreement. This will provide powerful new imaging and spectroscopy capabilities for broad use by the microgravity research community on ISS. To provide some background, here is how electron microscopes compare with light microscopes, which most everyone have had experience with. These tools are complementary, each with advantages and disadvantages. Light microscopes, left, have certain drawbacks such as limited resolution, contrast, and depth of focus. They can do depth sectioning due to their weak scattering. Electron microscopes, on the other hand, have advantages of higher resolution, contrast, and greater depth of focus, and due to strong scattering have excellent surface sensitivity. Both provide a form of spectroscopy. In the case of light, they are visible colors that we're all familiar with, and for electrons, the chemical composition is provided. Mochii is intended to be used for three main purposes aboard ISS. First, as a diagnostic device supporting crew and vehicle safety. Secondly, it will be made available for public use as a national laboratory facility for microgravity research and engineering. Third, it will serve as a platform for future mission research, including for Moon and Mars. After several years of detailed preparation, Mochii launched to the ISS on the NG-13 mission in February 2020, aboard the Cygnus space vehicle on top of a Northrop Grumman Antares rocket. This mission carried 7,500 pounds of supplies, food, and experiments, including Mochii, destined for the ISS. It was an amazing moment for our team to see a system we designed and built lift off the launch pad on a rocket and be propelled into low Earth orbit at 17,500 miles an hour. The Cygnus was captured a few days later after liftoff by flight engineer Drew Morgan and berthed with the ISS shortly after. In fieldwork, impacts to the body from the environment can range from mild to severe. On the Moon, for example, dust is extremely prevalent due to the electrostatic charge, which causes it to cling to fabrics and equipment, which then makes it onto the vehicle after EVA. At NASA Johnson Space Center, health researchers are studying inhalation of simulated lunar dust particles and its effect on the body. The researchers found that not only does dust naturally find its way into the lungs, some amount gets swallowed and makes its way into the gut. These are images of dissected rat intestine, which shows that grains of fine simulated lunar regolith dust, of sizes on the order of micrometers to tens of micrometers, embeds itself into the stomach lining. The composition is distinct, with the larger particles embedding into the convolutions of the intestine, while the finer dust also attaches to the smooth portions. These particles can irritate the linings of tissues and cause deleterious health effects over time. This type of knowledge has impacted the understanding of crew health during exploration and also can aid first responders as well as hazardous fieldwork situations. Electron microscopy is often used for examination of semiconductors and semiconductor packaging, and for reverse engineering products. This example is a failure analysis investigation we helped a small business to conduct with Mochii. During the time of coronavirus, many engineers and researchers cannot get into their facilities to use larger laboratory machines regularly. Mochii's ability to go anywhere enables work to continue unimpeded, whether at home or at customer sites in the field. In this investigation, a rugged diode used in a high-speed rotary power generator kept failing, throwing off its Kovar cap under a few thousand Gs and damaging the apparatus spinning at very high RPMs. The investigation using Mochii's spectrum imaging feature indicated copper concentrated at the interface seam, resulting in weakness despite the strong housing components. Likely failure mode was fatigue exacerbated by a segregation of softer metals to the seam. I hope you've enjoyed this presentation. In closing, VOXA is very excited to serve new analytical needs for both users on the ISS and in the field. Come visit us at projectvoxa.com, and we look forward to conversations with all of you. Thanks very much for listening.